Hey everybody, welcome back to your Dawn Drones podcast. I'm Dawn Zola, your host and the CEO of P3 Tech Consulting. We are at our second to last show of this year. This is the best of 2023, sponsored by Sagetech Avionics. And today we have with us the CEO of Sagetech Avionics, Tom Furey. So welcome to the show, Tom.
Hi, Don. Great to be here. And I just got to start with, I can't believe it's been a year since we did this last time.
Well, you know what? It's funny you say that because I was just going to say, Tom, I was looking back. This is your three-peat, my friend. So we're going to drop the links. Not only you have been with us since our year one on the Dawn of Drones, we have 2021 links. I think you were episode 18. And then 2022 last year, you were episode 71. And here we are well into the hundreds. So super exciting to have you back on the show, Tom.
Well, it's great to be here and I appreciate it. And I'll just plug the reason that we have continued and will continue is, and I'm sure we'll talk about this somehow later today, but we're an industry of collaboration. We have to be successful. No company can enter this industry alone. And you're like the ultimate connector for the industry.
Oh.
So it's great to connect with you and therefore be connected with the rest of the industry. So that's my pitch for you. How's that?
Oh, well, thank you. So that's quite the gift. Now that I'm all decked out for the holidays. I got my green lights going. We're just a couple days away from Christmas here and I'm super excited, but it's so great to have you back, Tom. And not everybody knows you. For those out there, Tom has this incredible background, United States I almost said Air Force, Tom, United States Naval Academy graduate. And Tom, why don't you just tell them a little bit more about your background?
Sure. You mentioned Naval Academy graduate, and then I flew an airplane called the A6 Intruder, which some people maybe recall. It was a great time flying off aircraft carriers. Taught me a lot about aerospace, taught me the love of it and the love of defense and protection of our soldiers, sailors, airmen, and Marines, right? And then I went from there into industry and started in aerospace and then drifted off into a variety of industries through manufacturing, engineering, and then general management. And then found my way to a company called Sagetech Corporation, where I was called up. I was living on the East Coast and called up by the owner of that company back. It's now, let me see, we're going into 2024, so it'll be 9 years.
Oh,
amazing. Wow. And just fell in love with the unmanned systems industry at that point. And in 2019, we had the opportunity to kind of acquire part of that company with a bunch of investors and then a couple of us from the company. So we started Sagetech Avionics and we just celebrated our 4th anniversary. So that's me. We live in the Pacific Northwest, so I love it here, and it's kind of similar to the Colorado area, but a lot of outdoor activities, mountain biking and wing foiling and windsurfing and things like that. And anyway, yeah, that's it. And I'm sure we'll talk about Sagetech in a moment.
Well, perfect timing. Let's do it. I know we've got a little video to roll. So why don't you talk us through Sagetech Avionics? Who are you?
Yeah, so Sagetech Avionics is a technology company. So we are a small business, but more than 2/3 of the people in our company are engineers working on research, development, and technical support of new products. We focus on airspace safety. So we've got a legacy history of providing the world's first and smallest aviation transponder, starting back before I even got here, 2010 with the old company. Those are the assets we acquired. So now we focus on providing civil certified transponders, military IFF, identified friend or foe transponders. And then we're currently working towards detect and avoid through ACAS-X solutions, which will help enable and do help enable BV lost flight for unmanned systems.
All right, very good.
Looks like I went too fast for the video. So
it's all right. It's just not synchronized, and that's all good. But you've got the commercial business, you've got the military business. There's your website where folks can learn more. Obviously, follow you on LinkedIn. You know what I love about your company too, Tom? Not every company does this. On your website, you talk about core values, and I know this harkens back to your time at the Naval Academy. And I don't, you did such a great job covering this with Maggie Schuster, by the way, last week. Everybody, if you missed Drone Law Connections with Maggie and Tom in that interview last Thursday, check that out on demand. Really great stuff. But let's just kind of list out those core values. I don't think we need to get into them. Folks can listen to that on replay, but I love that you have them, first of all, because so many companies don't. So tell us about that.
Well, let me just take one step back from that, because you're right. So personally, and you'll see our first core value is integrity, right? And that comes from my youth growing up, my upbringing, and then of course the Naval Academy and years serving in the military kind of drove that into me. But the reality is, when we started this company, Sagetech Avionics, 4 years ago, as I mentioned, it was acquiring assets from the older company, Sagetech Corporation, that went out of business, and it had some great things about it. It had some challenges. So the three of us that are here kind of as quote founders, even though we didn't start in a garage, one of the first things we did is we said, okay, this is what we're going to be like as a company, because we looked back and said, what was right, what was wrong, what can we do better and different, et cetera. And really that started us to define those core values. So right out of the gate, the very first thing we did, even before we defined what our mission and vision was and all that, was we defined our core values. I mentioned that integrity, and who knows what order they go in, because they're all equally important to us as a company. But integrity is one. Safety is another. And now I come from a manufacturing background, and safety reminds me of steel-toed shoes and not dropping heavy things on your feet. Right. But really, safety is what we're about. It's about airspace safety, safe integration, and of course, keeping us safe in manufacturing and in engineering. But really, it's about the products. High performance, because we're a small business. Quality, both quality of design, robustness, longevity of our products, as well as manufacturing quality. Customer focus, we literally bend over backwards for our customers, and sometimes that's painful, but we need them to be successful, so we'll be successful. And then finally, stewardship. We have investors, we have resources, natural resources, right? So both us taking care of our investors' resources, and then us developing products that reduce power consumption, and the whole drone industry of helping us be better stewards of the natural resources we have available to us. So you said not to explain them, I did, sorry. But that's it.
No,
it's six core values.
I love it, because you're just leadership personified. I'm not kidding. I love that you sat down with your team from day one, and you looked around and said, okay, what are we doing well? What can we do better? What do we need to stop doing? I think that's really hard for companies to do. Now, as you looked around, you guys decided there's problems out there that we need to be solving. And so let's start there, because you have a whole series of products we're going to talk about here, but there's kind of a problem statement that at your inception you were looking to solve. So what exactly is that problem?
So the problem is one that we envision could happen in the future, right? So we're sort of trying to mitigate the potential risk. And the bottom line is, we all expect and hope and pray for and Jetson land, right? Where we use the third dimension effectively for delivering packages, for delivering people, for communications, for you name it, right? I think we're in an era, we're at the dawn of an era, pardon the pun there. We're at the dawn of an era where we're going to really start seeing more and more crowded airspace, right? And we recognize that new entrants need to work and play well with others, but at the same time, it's going to create a much more complex traffic management environment. So we see that there are solutions there. That's the commercial side and the military side. Because, you go back 20 years ago, what we recognize right off is 20 years ago, if there was a drone flying a mission that was high tech and away from a base, or even just in the air, it was ours, or it was one of our close allies. Now, everybody's drone looks the same. So we clearly see and continue to see, as we throw more things like launched effects and loitering munitions and replicator programs at it, that we need to be able to correctly identify friend versus foe. Because going back to our safety, IFF and the DoD Ames office, which kind of governs that, is all about identifying friends and preventing fratricide. We don't want to shoot down our own assets. We don't want to shoot down our own people. We want to protect ourselves. We want to recognize when there's something that isn't one of our own or potentially isn't one of our own, so we can protect ourselves. So those are the problems we saw. It's really crowded airspace and crowded combat airspace. And our technology sits kind of right at the intersection of where we can help in both those.
Well, and not only that, but you looked around and saw that the technology that actually was available perhaps was maybe a little bit unwieldy. It was large, it was expensive. So, I mean, you guys have done an amazing job of reducing size, weight, while not decreasing power. So, tell us about that swap. And let's start on the IFF side, on the
Yep.
military side, because the MX12B transponder was really groundbreaking. And wasn't it the first one to be certified in mode 5S? Am I saying that right?
Mode 5.
Mode 5.
Yeah, and it was the first. I love stuff, right?
Yeah,
I have
show
to
and
make sure I
tell.
tell. And this wasn't even planned, but I always keep it there for these kind of
Yeah,
things.
do it, please.
But yeah, the MX12B was the first micro transponder. So the very first small transponder that was certified for mode 5. And this is it. And for those who don't know out there, I'll go through the 2-second rundown. I think we've done this before, right?
Yeah, so we go Dr. Zeus, right? Horton Hears a Who?
Yeah, but we start with Marco Polo.
Okay, go.
So so a transponder, whether it's a civil or military transponder, is like a Marco Polo. And if you've played that old game, it's like Marco Polo. There's a challenge and response. That's what IFF has been since World War II, right? An air traffic controller on the ground at LA Center or wherever interrogates, sends an RF signal up to an aircraft, and the transponder in the aircraft automatically recognizes that signal and responds with the Polo response to give it some information about itself. There's a thing called ADS-B on the commercial side that doesn't require that challenge. It's automatically telling everybody who you are and where you are, and truthfully, that saves RF spectrum through the number of interrogations and stuff. That's the Horton Hears a Who. And if you remember that one, that's the little on the dust speck. They're going, "We are here, we are here, we are here," and
Yes.
he just had to listen, and then he recognized that it was there. He didn't have to interrogate because he didn't have to know there was somebody on that dust speck, right?
Gotcha.
So that's transponders and ADS-B. On the military side, it's exactly the same, except it's all wrapped in a super secret password through a crypto computer controlled by the NSA. So that was when Mode 5 came out, which is like Mode S on the civil world, but it's encrypted. And that's basically if you're flying in a fighter or a Patriot missile battery or a ship, interrogates you, you respond, it interrogates you with the super secret password kind of thing.
Yep.
So you have to decode that and recognize that that's an interrogation. And then you respond with the proper super secret password. And when you do, they don't shoot you out of the sky, right? So that's what Mode 5 is. In 2021, the beginning of 2021, we were the first micro transponder to be certified. So
now
what was groundbreaking?
This transponder you're holding in your hand, just for context, this is like a deck of cards?
Yep.
Okay.
It's about the size of a deck of cards. It's about 1/3 of a pound. And this is, by the way, this is a keychain. I like to put it that way so I can show all the inner workings of it to people.
Oh, that's so cool.
Traditional ones, where we like to call them cinder blocks, but literally they were the size, if you picture a cinder block, or maybe a half a cinder blocks was a reduced size transponder. And they cost $100,000 or something like that, right?
How much do they weigh? Tom, how much do they weigh?
They would weigh the reduced size, the smallest ones that had been on the market, that half a cinder block, were probably about 6 to 7 pounds.
Holy shnikes. And so
Yeah.
when you think
and you
about
put that on a 40-pound airplane, it's not going to work, right?
Yeah, I mean, when you think about a drone, even a Group 4 in the military, Group 5, like a Reaper or Predator, putting 67 pounds additional on that thing.
6 to 7, not 67.
Okay, all right.
6 or 7 pounds. Just I would love if it was that much of a difference, but it's still a 10 times reduction.
Even 6 pounds from an aerodynamic standpoint is a big deal on a large drone.
Yeah, it absolutely is. So that's what was groundbreaking. But But yeah, I loved the way you mentioned the full power and stuff like that, because what we're just now starting to expose, if you will, right, is so the thing that appeared to be the best thing about this when we released it in 2021 was now we could put that mode 5 capability on drones. So
Yeah.
now you can identify a friendly versus a hostile drone. And I'll just put a plug in for my Russian counterparts. 2 weeks ago, there was a press release from Russia saying, hey, we are now putting IFF on drones because we can't tell the difference between ours and our enemies, and we're tired of shooting down our own drones. And I went, thank you, Russia. That's what I've been saying forever. Now, their IFF is different than our IFF,
Yeah.
but it's a problem for everyone, right? So that's what this brought. But at the same time, as you mentioned, we didn't, this isn't like we took an industrial product and dumbed it down for consumer grade kind of
Right.
thing.
Right.
This is an industrial grade, it's a military grade product, but it meets all of the specs that those big boxes did. And in many cases, it has more functionality than those big boxes. We now have DoD customers, and I can't go into great detail, that
Sure.
are looking at it for crewed aviation because it suddenly hit them like, wait a minute, we're paying more than twice as much as we need to, and we're wasting a lot of, you know, weight and space in our aircraft, and we could use this. Why would we not put that in a crewed aircraft and limit it to just uncrewed aircraft? So it was groundbreaking in bringing the capability to small drones, but it also turns out to be kind of groundbreaking in help saving valuable payload on our crewed aircraft for other things like fuel, like defensive armaments or whatever it might be.
Well, you mentioned Russia and they have a different IFF, but for NATO and our partners, they're using Mode 5. Is that right? Wasn't there like a standards change around the 2021 or
Yeah.
2022 timeframe on
In,
that?
in, in 2020, actually, what happened was they had used Mode 4. And the difference between Mode 4 and Mode 4, and that's what I flew with back in the day, right?
Mhm.
It's the same functionality, sort of. There's an interrogation an encrypted response, but it was very old encryption technology developed in about the 70s, right? So Mode 5 brings spread spectrum to help reduce the probability of intercept and probability of detect of the signal. It provides stronger encryption, but also GPS and new encryption aligned bring you more functionality. So one of the things that we were excited about this year in 2023 is we were the first, not micro, but the first of any kind of transponder to be certified with what's called Mode 5 Level 2 broadcast. So that sounds super detailed and geeky, but go back to what we talked about earlier. Mode 5 is you get interrogated by a fighter aircraft or a missile Patriot, missile battery or whatever, Patriot missile battery, and then you respond.
Yeah.
And that requires someone to know you're kind of there and interrogate you, right?
Right.
This ADS-B capability in the commercial world allows aircraft to see each other without relying on air traffic control.
Yeah.
Mode 5 Level 2 broadcast is essentially the same thing on the NATO and allied military side. It is encrypted ADS-B. And now what that does is you could put another version of this in the pocket of a soldier, and he can passively recognize that the drone coming in or the aircraft flying overhead is friendly or not and take appropriate action.
Wow.
You significantly reduce the kind of cost and weight across the armed services to have a better picture, situational awareness picture of the battle space around you. So that was, this was 2021 certified as the first micro Mode 5.
Yep.
But then in June of this past year, 2023, we're certified as the only certified Mode 5 Level 2 broadcast transmitter. And we're working on, and we'll likely be an early, if not the first one with a Mode 5 Level 2 broadcast receiver. And as we talk about future things, that's one of the things that we see coming down the road.
Well, now you know why they're the best of 2023. And so basically you brought Horton Hears a Who to the military side. Okay, very good. I knew I had it in there somewhere. All right, so let's flip over to the civilian side. So we're talking about ADS-B. Now, there's a lot of drone pilots and people in the drone industry that watch this show, and the FAA has precluded at least the smaller drones from broadcasting ADS-B out, right,
Yep.
Tom?
Yep.
But that doesn't mean so, but there's larger aircraft, for example, maybe larger cargo drones. Probably a good idea to have that on board, and obviously crewed aircraft. So tell us about what you're doing in this ADS-B arena and how it kind of dovetails into the future of the drone industry.
Sure. Let me first just talk about ADS-B, not a sales pitch for what we do, but why
Yeah,
it's
sure.
important. Um, it'd be great if everybody had ADS-B down to the smallest drone, right? So that we
Right.
can all speak the same common language and then see each other, recognize each other, avoid collisions, use it for counter UAS or whatever, right? But there's a reason that the smaller drones don't do it, and that is it's a single frequency, right? So there's only a certain amount of RF energy you can put in a single frequency. It's kind of like you and I talking, we can understand each other. If we were talking in a room full of people that were all talking at the same volume at the same time, we wouldn't be able to understand each other. And that's what would
Yeah.
happen if everybody was transmitting ADS-B in theory.
That's a great analogy, honestly. I've never heard it explained that simply and powerfully.
Yeah. So, but ADS-B is super important, right? So for smaller drones, we're looking at UTM and other things, but
Yeah.
ADS-B is important for smaller drones as well as larger drones on the reception side. As we look towards Part 108, which is kind of more entry into the national airspace thing, that'll be our New Year's gift, right?
No, I don't know. It's not going to be on New Year's Eve like the last
Yeah,
couple
I
of
know.
years. The FAA dropped something, in our inbox. But in any event,
Yeah.
continue.
So for larger drones, like you said, I mean, those are aircraft, right? They just don't happen to have a pilot on board, and they need to work and play well in the national airspace with the other people up there. And that's ADS-B is the best way to do that. And again, the reason for that is, Dawn, if you and I were two aircraft flying over Colorado, um,
Yep.
in the old days, you'd be on radar of, whatever it is, Denver Center or something like that. And I would be, and then they would let me know or let you know that we had opposing traffic and help
Yeah.
guide us from a collision. Um, that a better way would be if you send me a little signal that says you're there, and I send you a little signal that says I'm here, and we both recognize that. And that's, you can say that's the primary means and air traffic control is a secondary, or vice versa, but it's much more safe that way, right? That's what ADS-B on all aircraft up in the national airspace does for us. They can all see each other. Everybody else can see them on the ground, etc. Right? So it's important to have that. And then when we get to kind of Part 108, where essentially I'm sure we're going to be saying, right, that hey, there are certain right-of-way rules, but by and large, a crewed aircraft is going to have the right-of-way over an uncrewed aircraft. And that uncrewed aircraft maybe not transmitting ADS-B, but it needs to see those crewed aircraft so that it can avoid them. And ADS-B is a perfect way to do that. So having the right certified ADS-B receivers and then using the right avoidance logic, which is our other products, our collision avoidance system, now you can make sure that the larger drones can work and play well with others in the national airspace. The smaller drones can recognize and avoid crewed aircraft as well. Those are, I kind of hinted at, right? That's where we are focused. That's where our technology, our expertise, and our vision brings us. And that is the MXS, MODES, ADS-B in and out transponder, which was FAA certified last year in 2022. And that was the first small transponder, micro transponder, that had ADS-B in and out certified in the same box. And many thought that was not possible. But it was possible, obviously, right?
Oh, wow.
Um,
Very cool.
we continue to add on to that, which we have a lab use interrogator version of that, which interrogates other aircraft. But we'll combine that, and that's as we talk about future products, we're combining that with ACAS X collision avoidance logic, so that you have an all-in collision avoidance system. And if you add in other sensors to pick up those people who don't have ADS-B, or those drones that don't have ADS-B, like radar, your camera systems, et cetera. Now you've got a full detect and avoid. And for us, that's our near-term nirvana, right? Because having that in a dependable, reliable system will enable the FAA to grant routine BV loss requests, right? To say, okay, if you're equipped with this kind of technology, we believe that's one clear way to do it. Maybe it's not the only way, but we think it's one clear way to do that. That if you're equipped with this type of technology, ACAS-X based DAA system, then the FAA and we as citizens can trust that those drones that are flying beyond line of sight will be safe from swap and paint with other drones.
Well, I want to talk about, obviously we're going to talk about your ACAS-X, and I want to dig a little bit deeper in ADS-B, but before I do, I want to give a shout out to Greg Larson from AGS. Greg is out there saying that he loves the show. So thank you, Greg. Appreciate you. That's awesome. So you said that folks didn't think it was even possible to do ADS-B in and out in one box. Why is that, Tom?
So, I mean, others do it probably in a small box, right? So if you look at the things we do differently than traditional transponder and CAS manufacturers, right? Your big players who've been doing this for years, and they're very good at what they do, and many of our engineers came from there. You'll typically have like maybe a transmitter board and a receiver board, right? Well, we've got this all in one. We can't have a big box worth of RF stuff, and we can't isolate things as well.
Right.
So we just know that when we got that certification, or we were right about to get it at AUVSI in 2022, the Exponential show, right? We had a lot of customers coming to us going, you're getting both certified in the same box. We didn't think you could do that. Now, obviously you can, and it's just a matter of great engineering, and we have great engineers, and I'm not one, so I can say that freely, right? But we have a really talented team of engineers who can kind of, quote, do the impossible and bend the rules of physics at their will.
That's so cool. So let's talk about your ACAS-X then. And there's my understanding there's a family of ACAS systems, different, you're talking about ACAS-X, which is maybe this. Go ahead, you explain.
Yeah, I will. So and again, pull me back if I get too deep.
No, honestly, like I said on Clubhouse, I always learn from you every time I listen to you, and not everybody is super familiar with these systems, but yet they're so critical to safety in the national airspace system. So please explain ACAS, and then how the ACAS-X fits into the drone ecosystem.
Yeah, so let's first talk about where ACAS came from. And it's funny, we have I'll just go back to the values, right? So we, when you walk into our lobby, there's our logo, but then behind it, there's 6 plaques that each have our values. And each of those has an image associated with it that helps remind us what that value is, right? And the one for safety, the image is actually an artist drawing of sort of where we think we came from. Now that sounds weird, but there was a mid-air collision over the Grand Canyon in 1956.
Oh, that sounds.
And it was horrible. It was horrible, right? And air traffic control wasn't able to stop that. So 2 commercial airliners crashed, and everybody on board both lost their life. Clearly, that's an extreme example of what we don't want to ever have happen again.
Yes.
And I will say, our FAA, if you look at the history of aircraft incidents in the airspace, we have arguably the most crowded airspace and the best safety record that there is in the world. And that safety record has continued to improve year after year. So while, we all want to kick and prompt and push the FAA to move faster, we also applaud and recognize why sometimes they may move more judiciously to continue to improve that safety and protect it. So that thing right there in 1956, truthfully, I think that's part of why the Federal Aviation Administration was started. But I know definitely that started the research into TCAS, which is Traffic Collision Avoidance System. And that's an onboard system that will enable 2 aircraft to deconflict with each other to avoid a collision without requiring an air traffic controller to see them and to guide them and to help make sure that. So it's another layer of safety, and safety always needs to come in layers. You can't just have one layer of safety, right? So TCAS was started to be developed in the 50s. It was released by the FAA saying, hey, you're going to put this on commercial aircraft of a certain size and class in like 1981. And what TCAS was back then was you had mode A and C transponders. So these are just saying, they're not saying there's no GPS, right? So they're mode A says, this is who I am. Mode C says, this is my altitude, right?
Okay.
So part of a TCAS system is interrogating the airspace around it to see who else is out there, getting a return, and then using ways with directional antennas and this whisper shout thing to say, okay, I know where that other aircraft is, and then giving commands to the pilot to avoid that collision. As it's evolved, there was originally TCAS 1, which just said, hey, here's the aircraft that are around you, and this guy's a problem, right? It would just give you what's called a traffic advisory.
Okay.
But then that was TCAS 1. TCAS 2 came out later, and that would give you what's called a resolution advisory saying, here's that other traffic, and here's what you need to do.
Okay.
And TCAS 2 was a wonderful improvement. However, it's also limited in its applicability, right? So it required the aircraft, that the algorithm behind it was deterministic. And what I mean is, you're here, I'm here, therefore I'm going to do this, right? It's cut and dry. I don't really know where you're going, but I'm still going to, I'm here, you're here, I'm going to do this, right?
Okay.
And then it only gives me climb and descent. It doesn't tell me to turn left or right. It doesn't trust its directional thing. So it tells me to climb or descend. It also requires that you climb greater than 2,500 feet per minute. And it assumes you can fly, you are flying greater than 100 knots, right? Well, most of the drone world and helicopters don't fall into that sphere.
Okay.
Right? So it doesn't fit. Along comes ACAS X. So a couple of things. First of all, ACAS X uses a lot more. It's what's called a Markovian process, and trust me, it's developed by MIT and Johns Hopkins, right? So it's super smart, super well thought out, and I have no idea how it really works. But what I do know is, you and I are here and here, but now it's using your track history and your velocities and predicting where you're going to be, and it knows where I've been. It's predicting where I'm going to be. And now says, based on that, this is what you should do. And it can change that logic if situations change, right?
Okay.
So it's a better, more safe algorithm using prediction, but more importantly, it can handle any type of aircraft. So there's versions of ACAS X, and the whole system is called ACAS X. There's versions of it. So for small unmanned aircraft, and those are the smaller drones that aren't transmitting ADS-B, but receiving, right? It's called ACAS SXU. For larger fixed wing uncrewed aircraft, it's ACAS XU, and that's your Reapers and things like that, right?
Okay.
And then for uncrewed rotorcraft or crewed rotorcraft, any rotorcraft now, which was a problem. There was never a TCAS for rotorcraft. There's ACAS XR. And all of these systems enable, it doesn't just tell you climb or descend. It can tell you climb, descend, turn left, turn right, slow down even, right? It can give you blended maneuvers around these things. There are, by the way, also other versions that we don't look at too hard, but there's ACAS XA, which is for commercial airliners. That's kind of the drop-in replacement for TCAS 2.
Okay.
And then the ACAS XO for special cases, right? Two aircraft landing on parallel runways. You don't want them to be avoiding each other because they won't land.
Oh.
So, and if they're rendezvousing for refueling, right? So ACAS XO takes those special circumstances into account. So this whole family now is backwards compatible with TCAS, but enables everybody to recognize and avoid other aircraft through appropriate logic. But as importantly, I think we need a standard, right? I could develop my own logic to avoid another aircraft.
Right.
But nobody's going to know what I'm planning on doing.
Right.
And if you and I are coming at each other and I say, I got traffic, I'm going to turn right, and you say, I got traffic, I'm going to turn left, we're still going to hit each other.
Yeah.
So having logic and having a mechanism for aircraft to communicate with each other, what they're planning on doing, and having logic that is understood what they would likely do in a situation helps improve the safety case dramatically. So I went way down a rat hole. We saw the picture there. We have been flying this with customers, ACAS X computer. That's the picture maybe you just saw with your
Okay,
heat
that's
sink.
the ACAS X. Now, what about the SXU for the smaller drones?
It'd be the same thing, only
Okay.
we can have a single circuit card version of it. So this is a prototype. This coming year, we'll be releasing what's called our ACX family. So our MX family is this hardware platform that has military, civil, interrogator, other things on it. The kind of a circuit card. I'm not allowed to have the one with components. That's why there's an X on this. But a circuit card like this will be the ACX platform, and there'll be a military version with small mode 5. There'll be passive receivers for ground-based things, for around airport protection or integrated with other systems. And also this will be, a few dozen grams, so it can go on a small uncrewed aircraft to provide passive reception of ADS-B, reception of remote ID. It can use ground-based signals, and then it'll have ACAS SXU logic on it to provide an appropriate response to traffic.
So a one-stop shop, if you're talking about, and you mentioned a couple times Part 108. For those out there, I'm sure many of you know, but for those that don't, Part 108 is this beyond visual line of sight rule that we're all hoping is going to happen at some point soon, knock wood, and we're calling it Part 108, even though it doesn't yet exist, and BV loss is beyond visual line of sight. So just to clarify those two things. So Tom, with the products that you have, let's stick on the commercial side for a second. There's a lot of people out there looking around. The FAA doesn't have this rule yet, but they've been granting waivers, I'd say, on a more expedited basis. They had those 4 in particular that went out, on the Federal Register, that they're using almost as a template for beyond visual line of sight, that they ultimately published, I think, in the August, September timeframe, that if you're a company and you're going to do something just exactly like this, you should be good, and it'll be a lot quicker to get that approval. How have your systems, if you're willing to share, because we're talking the best of 2023 now, how have your systems contributed to some of these successes, some of these, operational breakthroughs?
Well, there's 2 ways. Not on any of those that were released, and those
Sure.
were awesome steps, and we continue to make steps. We
Yeah,
meaning the FAA, which isn't me, right?
exactly.
But we collectively, as an industry, and the FAA, continue to make step towards that nirvana of everybody routinely being able to just kind of file a flight plan and go, right?
Yes.
We actually our MXS ADS-B receiver, our ACAS situational awareness display, along with a radar, has a verbal approval for a groundbreaking waiver. So again, waivers that we continue to see are, kind of geographically bound in relatively small geographies and kind of a fixed concept of operation, right? This is similar, but way broader, bigger area, bigger ConOps, a lot more commercial use for infrastructure inspection and things like that. And so I can't say any more about that. The company whose airplane it is will announce that when it is received, but we've been working very hard to make sure things can be positioned for the FAA so they can see how these systems can enable that safety case. Secondly, we've also been putting the ACAS with MXS, and right now this is sort of prototype kind of thing, right? The ACAS and the MXS together.
Okay.
What we'll see next year is them sort of integrated, and that's the one of the versions of the ACX platform will actually look a lot like the MXS, but it'll have a daughter board with ACAS inside. But we've been working with some great OEM partners and some universities under the Assure 54 program that will see some of those test flights. And those are, if people aren't familiar with the Assure program, it's an acronym, and it's something about
Yeah, down in Mississippi. Yeah. In fact, it's so funny because I was just going through my office the other day and I found the card for Steve for Luck. Steve
Lux. Yep.
Yeah, down there. And General Poss, my good friend and colleague, stood up ashore. And for those that don't know it, it's a giant FAA affiliated clearinghouse really for R&D, where they're working with so many different universities and private folks in private industry to move the industry forward. So really exciting that you're in one of these programs working with folks. That's cool.
Yeah, and the one, and there's so many of them, right? So the project we're involved with is Assure 54. So you can tell there's been at least 53 others.
There you go.
And it's helping to define the right-of-way rules for beyond visual line of sight flying. That's what it will do. It will inform, right? Because even as waivers come out, we still need to collect more data. And as an industry and as an FAA, we'll still need to tweak the rules to be safe, right? But this will help inform that. It'll be putting ACAS logic as well as ADS-B receiver logic and transmitter logic where appropriate onto aircraft and doing some flights and some controlled encounter scenarios and things like that, again, to help inform those rules. So those are just a couple of the key areas. But, this is, aside from military IFF, this is really, those are our two primary focal areas really in providing safety to our warfighters and safety to our commercial air traffic.
Absolutely. And, you alluded to it. We're not going to have tons of time right now because we're getting close to the end. And I want to talk a little bit about the future and also how folks can reach you and what's up next. But, you talked about having a standard, for example, for ACAS. And I know you and your team are very active in ASTM 38, the working group 38. And some others on that. We talked about it quite a bit in Clubhouse, so definitely go back and listen to that. Was there anything you wanted to kind of hit on with regards to progress this year, since we're talking about the best of 2023, before we talk next about 2024 and what's ahead?
No, you mentioned that, the ASTM F38. One of the key areas that we work with is on the collaboration with RTCA, right? So for people who don't know, RTCA is a nonprofit organization that defines the product specifications and airspace specifications for the FAA to approve. So they work under the guidance of FAA, and it's a collaboration with the FAA regulators, with academia, with industry to come together and kind of define what these standards are. And a couple of those are critical, like SC 228, Special Committee 228, and Special Committee 147 of RTCA, defining things like DAA and like ACAS. And, those are things that we want to, I think, collectively make sure that as the FAA restructures and as they fight for funding, et cetera, those are things that can't lose momentum, because the adoption of those specifications, the granting of TSOs, and the ability to certify aircraft using certain equipment, those things need to continue to happen rapidly so that we can get to that future state that we all want, when uncrewed aircraft can be kind of approved and flown as regularly as crewed aircraft are today, right? So that's kind of the only thing I'll put out beyond what you just said about working with standards bodies. And then, I don't know, did you ask me to talk about what comes next? Is that?
Yes.
Okay.
Tell us about, so we're just 2 weeks out from the new year. Yep. And 2024 is going to be huge, I feel. What do you see? What do you see in 2024?
Yeah, so I'll talk about for us, what I see is more of the same, but different and better and faster, right? So I mentioned this, our engineers developed this MX platform to be super capable, but also flexible. And as you've heard, we're using it on ADS-BN receivers in certain areas. It's got a military certification. It's got civil certification. We have interrogator versions that are being used for, kind of weather stuff through some research institutions. A great flexible platform. The ACX becomes the next one. And there's two versions of that. There's a very small version of that, which is small, light, cheap, and can do ACAS and ADS-B reception and remote ID reception. we'll see further progress on that, and maybe even product release next year, but definitely further progress and prototyping with customers of that. And I think we'll also continue to see ourselves working with the military to see how can we make the military continue to advance technology, and how can uncrewed technology, how can these technologies like Mode 5 be used in uncrewed systems, and even smaller, lighter, like our ACX with a Mode 5 version on launched effects. And because picture the world when we have all these loitering munitions and launch effects and all this kind of stuff in the airspace. And if you're a fighter pilot trying to fly in through that and understand what are all these things in the airspace, and are they going to kill me or are they friendly, right?
Right.
Those are things that we'll be working on, and maybe we'll see some product releases. You'd mentioned to me, and we didn't mention on Clubhouse, I don't think, but one of the things that was new last year that we'd love people to come see, because we'll continue to evolve it, is, our engineers created some simulation tools for them to help prove out corner cases of if our software and our ACAS system's working, et cetera. And we suddenly realized, this is a really fun thing. So we have built up a simulator where basically we take it on the road to shows, and come see us at Exponential in San Diego this year. And it's been, I think that crate finally came back in late November, and it had been on the road since March. Going to different shows all around the country, where what's fun about it is it's a hardware in the loop simulator. So it uses just X-Plane. We're not simulator people, right? But you sit and you fly a Cessna, and then we have our ADS-B receiver MX at an engineer's house in Phoenix, right near an airport. It's receiving live traffic. The simulator simulates you being in the air at this moment over that airport. So the traffic you're seeing is live, and then it's giving you live collision avoidance cues. And what's awesome about it, and even though we tend to target our technologies towards uncrewed aircraft, the first time I got in that thing, I was getting collision avoidance recommendations that I should worry about somebody at my 1 o'clock, and I didn't see anything out there. And of course, I can see in the simulator what it looks like outside in the real world.
Right.
And then I got, hey, turn right now, you're about to crash, the resolution advisory, which gives you a safety buffer, but it's like a 15-second safety buffer. And as I started to execute that, that's when I saw the traffic.
Oh my gosh.
So think about that. Pilots today are relying on, 91, 113, see and avoid.
Yeah.
It's almost too late when you can see another aircraft. And my eyes are pretty good, and the simulator is pretty good. So ACAS, TCAS, now ACAS helps overcome that. So you asked what's new. That's not necessarily new, but it's always refreshed. Come see us at a show. Come see us at Exponential. Fly in the simulator and see what it's like to avoid a collision using modern technology.
Well, what a awesome note to end on, Tom. And how can people reach you in the meantime?
So Sagetech, you see it spelled right on the logo there, but sagetech.com is our website. That's the easiest way to reach us. There's contact us pages there. You go to LinkedIn, Sagetech Avionics, LinkedIn. You can look for me, Tom Furey, on LinkedIn. I mean, people aren't hard to find these days. You can find us. We'd love to connect, and we'd love to collaborate. I'll go back to what we said earlier. A transponder and an ACAS system isn't going to make what we want in the future to happen, but non-cooperative sensors, autopilots, control systems, UTM, aircraft systems, all of those things require us all to collaborate together to create success.
Absolutely. And I feel like 2024 is going to be the year of collaboration for this industry. I think we saw that happen increasingly this past year, and I think that's just going to accelerate as we blast into 2024. So thank you again, Tom. Hey, happy holidays. And to everybody out there as well, before you guys dial out, know that we have one last show of the year. By the way, the last Dawn of Drones, I'm going to say ever, because we're switching to the Dawn of Autonomy next year.
You scared me for a minute.
No, we're changing our name to the Dawn of Autonomy to more fairly embrace all the technologies that we routinely talk about on this show, and the fact that collaboration and, it's all about that, and all those technologies in one ecosystem. So next week, we're going to stream the best of 2023. So check that out. Grab an eggnog, sit by the fireplace, and enjoy the show. We'll see you one last time this year. So that's all she wrote, everybody. Thank you. We are out here.